So find the probability of x given n. So we have two events x. The student is in year 1. So the student is in year 1 and the student plays netball. And we have only 12 students who play these sports. Let's find the probability of x given n. So we have a basic formula. First we should find their intersection, which was 12 or 120, and we should divide it by probability of event n. 12 over 120 over, so the total number of students who play netball is 40. It's 40 over 120. So these 120s will cancel each other, and it's 12 over 40, which is 0.3. So we have a pretty similar question in B. Probability of n given x. So again, we define their intersection and divide it by the probability of event x this time, because this event is given here. So it's again 12 over 120, but this time the probability of x, the student is in year 1, so we have total 50 students in year 1. So it's 50 over 120, which, so again this 120s will cancel each other. 12 over 50, which is 0.24. Determine whether or not x and n are independent events. So to find that if they are independent events, we should find their intersection. Which was 12 over 120, and then you have to multiply each other, each of the events to each other, probability of x multiplied by probability of n. Okay, so probability of x was 50 over 120 multiplied by 40 over 120. So zeros will cancel each other, and here's 1, 3. Okay, it's 5 over 36. And we know that they are not equal, so it's not independent. But if they were equal, they would be independent events, as the outcome of one event is not affecting the other. But here, in this case, it is affecting. So one of the students who plays netball takes 8 shots at goal. On each shot, the probability that she will succeed is 0.15. So the probability is 0.15. Find the probability that she succeeds on fewer than 3 of these shots. You have 3 cases. First one, that none of the shots will succeed, and you have only one shot succeeded, or 2 shots, and their sum gives us this. So probability of x less than 3 equals to the sum of this. So in the first case we have 8 failures. So probability of success is 0.15 and Q is 0.85. So it's 0.85 raised to the power 8. And we add. So in this case, there's only one succeed. Okay, so 0.15 but we should multiply it by 8C1 because we don't know when the shot will succeed, which shot will succeed, so we have to multiply it by 8C1, and we have 7 failures again. So, and in the last case, we have 2 successes, and again we should use 8C2 because we don't know in which order they happen. So 0.85, and we are having 6 failures this time. And the answer is 0.895 in 3SF. Find the number of different arrangements of the 9 letters in the word algebraic. So you have 9 factorial over, you should find the letters which are repeated in the word. So you have only 2 A's repeated, so it's 2 factorial, which gives us 181,440. Okay. The number of different arrangements of the 9 letters in the word algebraic in which there are no more than 2 letters. So it's no more than 2 letters between 2 A's. So you have 3 ways of arranging them. First one is putting 2 letters between A's. 5, 6, 7. So you have all other 7 letters arranged in whatever order they want. So you have total 7 factorial number of ways of arranging them, and we can change the places of A. For example, they can be here, or here, or here. So there are a total of 6 ways of arranging 2 A's, so it will be multiplied by 6. So in and we can put 1 letter between A's. So again we have 7 factorial for other letters, and this time we can change the places of A's by like putting only one letter between A's. So we have total of 7 ways of placing A's. So it will be multiplied by 7. And in the last, the 2 A's will come together. So they can be considered as one block. And we have other 7 letters. 5, 6, and 7. So because they are considered as one block, we have total of 8 blocks, so it will be 8 factorial. So it's 30,240. It's 35,280 and 8 factorial. 40,320. And we should add them together to find the total number of arrangements, which will be 105,840. So a fair coin and an ordinary fair 6-sided dice are thrown at the same time. The random variable x is defined as follows. If the coin shows tail, x is twice the score on the dice. If the coin shows a head, x is the score on the dice if the score is even and x is 0 otherwise. So if it's odd number, it will be 0. So draw up the probability distribution table for x. So first we should find the possible values of x. So it will be 0 first if it shows a head and an odd number, or it can be, so it can't be 1 because if it shows a tail, the score, if the score on the dice is 1, it will be multiplied, so we get 2, and if it shows 1 after a head, it is considered as 0. So we have 2, so we can't have odd numbers here. And here, because the score on the dice will be multiplied by 2, we can get 8, 10, and 12. So first let's find when we're having 0. So it should, so the coin should show a head, and you should get odd numbers on the dice. So it's 1 over 2. So it's total 1 over 4. So it's 4, 0. And when we are having a score of 2, so either it should show a tail, which is 1 over 2 multiplied by, and we should get 1 from the dice. So it's multiplied by 2, and then we get 2, or it should show a head, and we should get 2 from the dice. So it's 1 over 6. So here it should be 1 over 6. Yeah. And to get 4. So the same logic goes for 4 and 6 also. 1 over 6, and for the score of 6, so it should be, but for 8 we have only one way of getting 8, because here if it shows a head, x is the score itself, and we don't have a score greater than 6 on the dice. So we can get 8 from only the first way. If the coin shows a tail, x is twice the score on the dice. So it should show a tail multiplied by the score, twice the score on the dice, and we should get 4 from 6 numbers. So it's 1 over 12. And the same logic goes for 10 and 12 also, as they are greater than 6, and we don't have a number greater than 6 on the dice. So let's draw probability distribution table. X equal x. Okay. So we're having 0 when it's in 1 over 4, 1 over 4, it's 1 over 6, it's also 1 over 6, 1 over 12, 1 over 12, 1 over 12. So their sum should be equal to 1. So here we should find the variance of x. Variance of x is equal to the mean of x squared minus the square of expected x. So from the calculation we can know that this will be 35 and the mean value will be 4.5 and its square. So the variance is 14.75. The heights in meters of white pine trees are normally distributed, so it's normal distribution, with mean 19.8 and standard deviation 2.4. In a certain forest there are 450 white pine trees. How many of these trees would you expect to have height less than 18.2 meters? So we should find the probability of getting less than 18.2. So as you know, to find z we have to subtract from 18.2 our mean value, which is 19.8, over standard deviation, which is 2.4. So to find its probability we will have to, so because it gives a negative number, should subtract it from 1, the value of 0.667. And in the exam we will be given an MF 19, so here had 0.667, so we should find from the normal distribution table its value. So it was 0.6, so 6, and we will add here 7. So if we subtract its value from 1, we will have 0.25, 3, and we had 450 white pine trees. So if we take 450 white pine trees, so we will be having approximately 113 white pine trees. So because it gives non-exact numerical number, it would be either 113 or 114. The heights in meters of red pine trees are normally distributed with mean 23.4 and the standard deviation. It is known that 26% of red pine trees have height greater than 25.5 meters. Find the value of standard deviation. So let's first write a statement that we have. So probability of getting x greater than 25.5 was 0.26, and here we do reverse of what we did in 4a. So first we will find a value of z, which gives us 0.26. And in normal distribution table we don't have a value which is less than 0.5, so we can find a value which gives us 0.26 when it is only subtracted from 1. So 1 minus 0.26 is 0.74. So the negative 0.74 will give us a value of 0.26. So it should be somewhere between these two. So the closest number is 10. If we add 10, it will be closer to 0.74, so it's 0.6, 4, and 3. So it's 0.643. But we are having its negative, and here we can see it is saying that x is greater than 25.5. So when we are finding the probability, it will be probably like this. So 1 over 4 x being greater than the number, and here we're again subtracting the value of 0.643 because it is a negative. So these two will cancel each other, so we'll have 0.643. So we know that the z equals 0.643, and we have a formula which is x minus mean over standard deviation. So let's substitute the values. So 0.63 equals to x minus, so not x, we're substituting it with 25.5 minus the mean 23.4 over standard deviation. So if we calculate it, it will give us 3.27 in 3 SF. In a class of 21 students, there are 10 violinists, 6 guitarists, and 5 pianists. A group of 7 is to be chosen from those 21 students. The group will consist of 4 violinists, 2 guitarists, and 1 pianist. So how many ways are there of 7 to be chosen? Okay, so we use here combination, and we know that we have a total of 10 violinists. So we are choosing 4 of them, and we have a total of 6 guitarists, and we are taking 2 of them. And here we have 5 pianists, which we should be taking only 1 of it. So our calculator gives us 15,750. Okay. On another occasion, a group of 5 will be chosen from these 21 students. The group must contain at least 2 violinists, at least 1 guitarist, and at most 1 pianist. So how many ways are there? Okay, first we should list all the combinations that we can choose from these 21 students. So at least we should have 2 violinists and at least 1 guitarist. Okay, first we will have then 4 violinists and 1 guitarist, and then we will have 3 violinists and 1 guitarist. The reason we are not taking here pianist is it's only mentioned the most, like the maximum number of pianists should be 1, so it can be 0 also. Okay, here we can take 2 violinists, 3 guitarists, because here it's saying only the minimum value, and here we cannot take 1 violinist because it should be at least 2, and the guitars should also be at least 1, and at most 1 pianist. So we can here take 1 pianist, and here also. So total we have 5 combinations, and we should be calculating the number of combinations for each of these cases. So here we have like we had total of 10 violinists, and we are choosing only 4 of them. We just multiplied by, we had 6 guitarists, so 6 C1. Okay, and this should give us 1260, and here we have 10C3 because we are taking 3 of 10. Okay, violinist, and here we have 6C2, which will give us 1800. Okay, same goes here, 10C2 multiplied by 6C3, which gives us 900. Here we have 10C2 multiplied by 6C2 multiplied by 5C1, which gives us 3,375. Okay, here we have, in the last case, we have 10C3 multiplied by 6C1 multiplied by 5C1, which gives us 3,600. And total, we have the sum of all these combinations, which is 10,935. The teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in the table. So we have a table of times taken in minutes. So we have to draw a back-to-back stem and leaf diagram. Okay, with the Falcons on the left hand side. So we have Falcons here and Kites. When you are drawing a stem and leaf diagram, first thing we should look for is the least value among the runners. Okay, so we have 32, I think this is the minimum value, and we have 76. So the values start with 30s and end with 70s. So we have 3, 4, 5, 6, 7. Okay, let's do this. Okay, so we have in Falcons 38, 39. Like we have only two times starting with 30s, and we have 42, 44, 46, 48. We have 50, 51, 52, 56, 58, 59. And whenever we are drawing back-to-back stem and leaf diagram, we should always start the least value from the center, and it goes away as the number increases. For example, the 50 should be here, not in the end. And as the number is increasing, 51, 52, it is going away from the center. So starting from 60s, we have 64 and 69, and we have 76. And in Kites, we have 32, we have two 40s, 45, 47, 48, 52, 54, 58, 59, and 59. We have 60, 61, 63, 65. Okay, we are done with our stem and leaf diagram, and here we can make a comment. For example, we can take this part and explain what does this mean. So 240 means 24 minutes for Falcons and 42 minutes. Yeah, and 40 minutes for kites. So I'll be solving B part of the question under our diagram, so it will be easier. Okay, here we have to find the median. We had 15 runners, so we have 7.5, which means we should be looking for the eights. Okay, here we can see 1, 2, 3, 4, 5, 6, 7, 8. So eighth runner took 51 minutes to finish the race. Okay, so we have to add median was 51 minutes and interquartile range. So to find interquartile range, we have to subtract lower quartile from the upper quartile. Okay, 3 or 4, which gives us 11.25, which means we should be looking for 12s. And for draw on 15/4, which is 3.75. We should be looking for the 4s. Okay, so the 4s is 44, so we have 44 here, and 12s 4, 5, 6, 7, 8, 9, 10, 11, 12s. Okay, 59. So 59 minus 44, and we have 15 minutes of interquartile range. Okay, let X and Y denote the times in minutes of a runner from the Falcons and a runner from the Cats respectively. So here we have the values. Find the mean and standard deviation of the times taken by all 30 runners from the two teams. So I have to add them together and find the new average time taken by all of them. Okay, which means our mean will be 783 over 30, which is 52.5. And we should also find the standard deviation. We have a formula of sigma x squared over n minus mean squared, and we have to take square root of this. And here, do not confuse this x with that one, because it's just a formula. Now we will be substituting with our values. So we have to add these to sigma x squared and sigma y squared. Okay, let's write this. 43,504 plus 42,223 over 30 minus 52.5 squared. Here we have already found our new mean, so we are subtracting from it, and here it's square root. Okay, let's calculate it in our calculator. Here it gives us approximately 10.1 in 3 SF. So in a game, players attempt to score a goal by kicking a ball into a net. The probability that the lineup scores a goal is 0.4 on any attempt, so independently of all other attempts. The random variable x denotes the number of attempts that it takes Leno to score a goal. So, okay, here we have to use geometric distribution, and let's do it. 5 equals to probability of failure of power raised to 4 multiplied by p. which is 0.6. As you know, the probability of failure is 1 minus probability of success multiplied by 0.4, and it is 0.0518. Okay, here we have to find that it will be no more than 7 and greater or equal to 3. So simply we have to find, so let's rewrite this. So simply we have to find the sum of the probabilities. Okay, so and we will have equals 7. So which means, so here we are using geometric distribution again, but we're doing it separately for each of the numbers starting from 3 till 7. Yeah, here we are using, for example, 0.6 squared multiplied by 0.4. So this is one of them, and here we have 0.6 raised to cube multiplied by 0.4, and in the last we will have 0.6 multiplied by, so raised to power 6, sorry, multiplied by 0.4, which in total gives us 0.332 in 3SF. Okay, find the probability that Leno scores his second goal on or before his fifth attempt. So it means that he has already scored one goal, so it can't be on first attempt, but it can be on his second, third, fourth, or fifth attempts. So let's find it. Okay, the probability that he scored on his second attempt, like his second goal on his second attempt, will be scoring on first attempt, so it's 0.4 multiplied by 0.4 again, it's like first attempt and it's second attempt. Okay, so I think this will be 0.16, and here we have, so here we use 0.4 multiplied by raised to square multiplied by 0.6. So we know for sure that we had one failure and two successes, but we don't know their order. Like we know that third attempt was success, but we don't know about the first and second. So we have to multiply it by 2C1, and here also. So we know that in the last attempt it had 0.4, but we don't know what happened before it. So we are multiplying 0.6 squared by 0.4 squared, and we are multiplying them by 3C1 because we know that the fourth attempt was success, but the 3 attempts before it, in which order they happened, we have no idea about it. And in the last we have okay, 0.63 raised to 3 multiplied by 0.4 squared multiplied by 4C1. Here also we know that the fifth attempt was success, but we don't know about the previous 4 attempts, but we know that there was 3 failures and 1 success, so we are using 4C1. And let's find the values here. Okay, 0.4 squared multiplied by 0.6 multiplied by 2, so it's 0.192. 0.6 squared multiplied by 0.4 squared multiplied by 3, so it's 0.173. 0.6 squared multiplied by 0.4 squared multiplied by 4. So 0.138. And the total probability will be the sum of these four cases, which is 0.6663. So Leno has 75 attempts to score a goal. Use a suitable approximation to find the probability that Leno scores more than 28 goals but fewer than 35 goals. So here we need to first find the mean and the variance. Okay, the mean is, so write it x, as we know its formula, it's NP, so number of attempts multiplied by probability of success, which gives us 30. And we have to find the variance, which is NPQ, so number of attempts multiplied by probability of success multiplied by probability of failure, which gives us 18. So we know that it is a normal distribution with a mean of 30 and with a variance of 18. And here it said more than 28 goals but fewer than 35 goals. And also we have to use approximation, which means we have to find the probability that it will be more than 28. So if we use approximation, it should be more than 28.5. Yeah, x, and it should be less than 35, which means it should be less than 34.5. Yeah, okay, which means 28.5 minus, so we are trying to now represent this in z, like, as you know, the formula of finding z is x minus mean over standard deviation. Okay, so 28.5 minus 30, our mean, over square root of 18. Sorry, it should be like this. Okay, set, and here's 34.5 minus 30 over square root of 18. So which means, so first we let's find the z values itself. Okay, so it means probability, okay, it's negative 0.354 and 1.061. Okay, first let's find this part, which is phi 1.061. So if we have a normal distribution, okay, here it might be 30, and where 28.5 is somewhere here and 34.5 is somewhere here. First thing that we should do is, so we are trying to find the area in the middle. Okay, so first thing that we should find is find the left part of 34.5, which means find this part. Okay, so we are representing it with phi of 1.061, and then we have to subtract this area. Okay, so here it is a negative value. However, here it's z is greater than it, so which means to subtract it. Okay, 1 minus phi of 0.354. Okay, here if you find their values from distribution table, we will have 0.8556 minus 1 minus 0.6383, which is equal to 0.494 in 3 SF.